Hello, sir. No, sir, you still didn't release the PDF and code samples from yesterday's lecture, sir.
Hi, yes, I should be releasing them today. So I just need to upload them and make sure they're on the correct lessons tab.
Okay, sir, thank you.
Cool, you're most welcome. Let me just make sure the music's not too loud. Are there any questions before we get started? Just let me know. Also, is the latency between you hearing me speak and you speaking on the Google Meet, is that fine now?
There's still a lag, like, I'm pretty sure me talking is going to be a 5-second delay, but it's not really a problem.
Okay, okay, that's good to know. By the way, I put the link to the stream in the chat. If one of you wouldn't mind...
5 seconds, like, so just say 1 or 2 seconds.
Okay, cool. If one of you wouldn't mind putting it on the WhatsApp group, I would appreciate that.
Just I think, sir, no, if I talk to sir while sir's talking, I'm not doing it on purpose. It's just because of the delay.
Yeah, that's fine. Might also help to just mute the stream, but then you might not be able to hear me. It's tough. I think this, with the delay, it might just work a bit better for when people watch it later.
Mute myself and unmute the stream.
Yeah, that's true. You're also welcome to post in the chat of the YouTube stream as well, hey? So if you don't feel like talking, you're welcome to post in the chat.
And I prefer speaking verbally because I'm too lazy to type.
Of course. We encourage laziness if it leads to efficiency. All right, we'll give it another 2 minutes and then we'll get started. Maybe I should figure out a way to put a timer up on the lecture thing. Maybe like a countdown timer to when this lecture is going to start. All right, everyone. It's 5 past. I think we can get started. Let me just bring down the music. And today we'll be talking about arrays and multidimensional arrays. All right, everyone. It's 5 past. I think we can get started. We're getting some feedback, so if you hear some feedback, let's mute. Yeah, thank you. All right. Today we're going to be talking about multidimensional arrays. Correct me if I'm wrong, but you guys didn't really touch on this in 3rd term or in Python. So we're going to have a look at it, and then we'll look at some cool array tricks. And this should cap off the files, IO, exception, and multidimensional arrays portion of term 4. So this is the last lecture this week. Tomorrow will be a consultation session. And remember, your first assignment is coming out tomorrow at noon. This is it's just going to be working with files, working
tomorrow's consultation session, it's the same time, 4 to 5.
Yes, same time. So 4 to 5, it'll be a consultation session. It'll just be Google Meet. It won't be the live stream. It will still be recorded in case people want to have a look at it. But yeah. Or well, you know what? We'll do a live stream.
We're releasing our track tomorrow, so doesn't that mean we can also go through that during the session?
Yes. Yeah. So if you have any questions, that's the whole point. We'll release the prac at 12. You'll have a chance to look at it, and then at 4 to 5, you can come ask questions about the prac. All right. So if there are no more questions before we begin, cool, we can get started. So I'm just going to recap some arrays with you, and then we'll look at multidimensional arrays. We'll recap array lists, which I think you've done as well, and we'll look at some tricks with arrays. So to begin, we'll have a look at how we declare and initialize arrays. Just a brief reminder, when we declare variables, we have to specify a type. So we'll look at how we declare an array with a certain type of element. Then we will initialize, and when we initialize something, we give it a beginning value, or we set the value at the beginning. We'll also look at array elements and how you index them, looping, sorting, searching, and then the 2 new things that you might not have encountered will be partially filled arrays and multidimensional arrays. So multidimensional arrays are very cool because they can be used to represent something called a tensor. And a lot of tensor mathematics is used in machine learning and deep neural networks. So that's kind of the real world application of multidimensional arrays. There are lots of other applications for multidimensional arrays. This is just one that's quite popular at the moment. So as you know, an array is just a data structure that contains elements that are indexed. So it's a collection, right? It's a bunch of elements of the same type that are put together in a block of memory. The array is called the collection of elements, and they each have an index or a position in the array. The element is a value or a variable at a specific index, and then the index is just a position. In computer science, because we're strange, we start indexing at 0. A lot of people trip themselves up with this. So if an array has 5 elements, the indexes would be 0, 1, 2, 3, 4, right? If you try to access index 5 in an array with 5 elements, it'll be out of memory. It'll be out of bounds. Before using arrays, we must actually initialize them, so give them kind of a length and a size denoting the number of elements.
Connected to battery 100%.
And so when we denote the elements and the type, then we can start working with them. Before this, the memory is typically unallocated. So when the memory is unallocated, we can run into an issue of invalid memory. Java luckily doesn't let us do this. It'll give us compile time errors. And for now, we'll look at fixed size arrays. Later on, we'll look at ragged arrays and multidimensional arrays, and then array lists are used for changing or having variable sized arrays. So you should already know how to create, say, an integer array, right? You just say new integer array. Notice the new keyword here. This gives us a block of memory, and that memory is 5 integers big, so they're all put together in memory. Okay, it's quite an efficient way to store a whole bunch of numbers together. You can also do the following, where you can declare it first and then initialize or allocate new values to it, right? So you can kind of let Java know, prepare for an array of integers and then assign it some values. You can also use the array literal, which is the squiggly brackets. I'm not sure if you've actually encountered this before, but this is in Python. These will be square brackets, right? Because the braces represent a dictionary, but in Java we use the squiggly brackets to represent an array literal. The array identifier is a reference variable. So someone was asking before, when they did their test 1 and they had their data array, they were getting a really strange kind of, square bracket @ variable name or value from their array. And that is actually the reference to the point in memory where that array was stored. Okay, so when we print out arrays, we actually need to iterate over every single element and print it out individually. Or we need to index some element and print it out. Otherwise, if we just try to print out the variable, we will get the reference, so the address in memory where the array is stored. So the length of an array is the number of elements. You guys all know this. There is 0 index. This is what we talked about before. And this means that the last index in an array is the length minus 1. All pretty straightforward. If you try to access anything that is less than 0 index or greater than the array length minus 1, you will get an out of bounds error. We use the index or the subscript notation to access elements. So we'll give our array identifier or a variable name, and we will use square brackets to access the actual value at that index. You may use any valid integer arithmetic expression. So this is something that is very interesting. As long as the expression that you wrote, so plus, minus, times, divide, ends up an integer that is within the bounds of the array, you can use that. So the following is valid, where we have 2 times 5 plus my integer minus 10. And if this ends up to be, within the array bounds, that's valid, and it will access whatever this turns out. So whatever this equals, it will access that element and set the value to 0. Is everyone with me so far? Okay.
Yes, sir.
All right. So array elements can be treated as a variable of that type. It's possible to use special assignment operators on them, increment or decrement operators. We can change the value. We can use the value in other calculations. All very straightforward. The array is just a block of, you can view the array as a block of variables of that type. Okay. Arrays can be equal in one of two ways. They refer to the same memory address, so they have the same reference, or they have the same content. So does this make sense? If they point to the same memory address, then they're accessing the same memory, so the values are the same. And if they have the same content, but they might be in two different addresses, then they're also equal, right? And this is what we run into when we try to use the equivalence operator. So if you use the equivalence operator, equals equals, this means that the left-hand side is equal to the right-hand side. However, if you use this on arrays, it only checks if the references are the same, not the content. So every time you call a new int, it creates a new reference, right, in memory. It points to a new place in memory. So if you then try to use the equals equals sign on two arrays that were created with different new statements, they won't be equal, even though they might both have the same content. Okay, so this is a trap or a pitfall. Assigning an array to an array variable duplicates the reference and not the content. So what this means is that if two arrays point to the same memory or have the same reference, modifying the one will modify the content of the other as well, because they're sharing the same memory. Does that make sense to everyone? Do we have any questions? Okay, I think we're good. If you have any questions, feel free to interrupt, hey? Okay, I don't see anything in the chat. We should be fine. So, looping through an array, we can do it in a multitude of ways. We can use the fully specified for loop, right? So we go from index 0, index array length -1, and go through every index. Okay, yeah, thanks. I see someone posted in the YouTube chat. I appreciate it. It helps me see and interact with you guys. We can also use a for each loop, which is a much more condensed way, where the big difference here is that instead of having to index the element or access the element by the subscription notation, we actually just pull a copy of the element out of the array at every loop, right? The for each loop works with the value of an element. The for loop, this one, works with the index that is used to access the element. So we can also sort. We can use the java.utils.arrays library or package, and we can use a sort functionality. Sort will sort the array in memory where it is. It doesn't create a new copy that is sorted. Okay, so it's typically viewed as like an irreversible operation. Sorry, my language got mixed up there. Irreversible, because once we call sort and it's sorted, there's no way for us to unsort the array. Okay. You can also write your own sorting algorithms, such as the selection sort. There are a whole bunch of sorting algorithms like quicksort, heap sort, bubble sort, merge sort. Go have a look at arrays.sort, see which sorting algorithm it uses. I think in second year you will get into algorithms formally, and you will do sorts and search algorithms. You can also look for specific values and find an index of it. So you can do a linear search, which is going through every element in the array one by one by one and looking through and see if it matches your element. You can also perform something called a binary search, where you keep splitting the array in half and checking if the value is greater than or less than the middle value. This only works on a sorted array. It doesn't work on an unsorted array. A linear search works on any type of array. Okay. Linear search tends to take longer or is less efficient operation-wise. A binary search is more efficient, but the idea is that you need to have your elements sorted already. The syntax for binary search is arrays.binary search. The array that you're searching, you can give it a range, so a start index and an end index, and then you give it the search key, so the element that you're looking for. This type must be the same as the array type, and it can be, integer, string, Boolean, whatever. Although I can't imagine searching a Boolean array would be very effective. Searching a Boolean array, you would pick any index either one way or the other. The binary search returns the index of the first matching element, right? So if you have repeating elements, the binary search will return the first matching element. So a partially filled array. Previously, we might have been working with fully filled arrays or complete arrays, where every value has been, every index has been given a useful value. How does collection.sort and arrays.sort differ? Collections.sort works on something using an interface. So we'll touch on interfaces when we do object-oriented programming, but essentially it's a more general sorting method. Arrays.sort specifically only works on arrays and primitive arrays or array lists, but specifically primitive arrays. Whereas collections.sort works on array lists, queues, stacks, a whole number of what Java calls collections or collection data types. So collections.sort is much more general and flexible, whereas arrays.sort only works on arrays. All right. So a partially filled array is where not every single element has been given a useful value that we would want to access. So to work with partially filled arrays, we keep track of the number of elements, or at least in our very basic rudimentary method, we can keep track of the number of elements that have been inserted into the array starting at index 0. So we fill an array starting from index 0 until the end of the array. The number of elements also indicates which would be the next open index in the array. And so we assign we can assign every element an initial value after creating the array, right? So it is possible to have arrays of arrays as well. So with a partially filled array, I just want you to think about it for a second. This might be, say, how if we're calculating marks, we don't have all the marks for all of the assignments, right? So we might have an array of 8 different indexes which contain floating values, and we've only done 4 assignments so far. So we will fill in the first 4, and we will say we have filled in 4 assignments. We'll keep track of that number, and then when we need to add another assignment mark, we will add it at index 4. All right. I'll maybe show a demo either today or tomorrow, just to make it a bit more clear. Then we have this idea of multidimensional arrays. So a multidimensional array is just an array of arrays. Okay, and you can go arrays of arrays of arrays, and there'd be arrays all the way down. A most common way to think of a 2D array is something like an image, a black and white image. It's a grid, and each pixel is either 1 for on or 0 for off. And so an image would be, 200 pixels by 200 pixels. So it'd be 200 by 200, or 200 arrays of 200 integers. And those would give you the values of the pixels, right? So multidimensional arrays are quite useful. The way that you declare a multidimensional array is you just add another square bracket pair or a hugging square bracket pair for every dimension that you need. For now, we're only looking at two-dimensional arrays. We're going to be looking at rows and columns. That's the way we'll think about them. It's a bit easier. And they must be fully indexed in order to access them. Okay. The reason why we say if you want to access an element of a multi-dimensional array, you need to fully index, is because if you just gave the row, so my array row, this type is not what the element type is. This type, so just this over here, is actually going to give you an array. And then you give it the other index for that array that will give you the element. Okay. Is everyone with me so far? Are you following? Okay. If you get lost at any stage, please feel free to interrupt and ask me to explain. Okay. Okay, yes, following. Good, good. I'm glad that you're following. So we can use multiple for loops to go through every element in the array. So nested for loops, right? For a two-dimensional array, we need two for loops, one for the rows, one for the column. And then we can go and say row, column, and that will give us every single element in the array. You can also do this with for each loops. However, you need to be careful. The outer array will give you an array element, right? So this will give you an array element. And then for this element, which is an array, we want to go through each of its items, which is the actual type of the value we're trying to use. For 2D arrays must nested for loops follow. Only if you're trying to go through, or any nested loops. Any nested loops, as long as you go through, as long as you manage to go through the full range. If you're trying to access every single element in order, you can go through the full range with nested loops. Yeah, so it's usually nested. It makes it a bit easier for us to understand and read. So you can either use the indexing method, right, with rows and columns. This is often useful if you want to skip certain indexes or indices. Or you can use a for each. The only catch you need to look out for with for each is that the first type is actually an array. And the second type is the type of the elements. Now we're going to talk about something called ragged or jagged arrays. And these are multi-dimensional arrays where the sub-arrays are not all the same length and size. So with our 2D arrays before, we've assumed that they are grids, right? They're square matrices or matrices where the dimensions are the same for the sub-arrays. However, you can have jagged arrays. Okay. With the jagged array, this just means that you're creating different length arrays in your multi-dimensional arrays. So the idea being is that your array will end up looking something like this. Right? Where each of the subarrays in 0, 1, 2, 3, right? So these are subarrays over here, where each of these subarrays have a different length, right? But this original array of arrays pointing to all of these is the first length that you give it. Okay. So we say here, my array is equal to a new integer multi-dimensional array where we have 3 different arrays, and then each of those 3, the first one has 1 element, the second one has 5 elements, and then the third one has 4 elements, right? So I guess that would be close to 4 elements. Right. So you need to be careful when looping through and indexing jagged arrays. It's a bit easier with for each loops, but you need to be careful because you need to index them properly. So make sure to check the length of the array that you are trying to access. This is always a good idea. So if you use array.length, or here we index with the row, so we should actually say row in here. We will always be safe because we're working on whichever array we're trying to access, the length of it. Okay. Same thing for each, but for each will handle it for you. So if you want to use jagged or ragged arrays, just be careful of that. Now, this next slide seemed to just not work out very nicely. What happens if we want to increase the size of the array? We either have to create a new array with a new length and then copy every element over, or we can use the array list. Okay. You've already worked with the array lists. So an array list is a dynamically resizable array. It's part of the collections, I think. I'll just have to double check.
I find the array list much better to use an array, like it's user-friendly, I think.
An array list is very nice because it's flexible and you can, remove elements, add elements as you see fit, and the length problem is solved. However, an array list has a bunch of supporting data as part of the data structure. So it has a bunch of extra methods and extra information to keep track of things than a normal array. And as such, it's not as high performance as a normal array. It's not as memory efficient. Because you can imagine a normal array is just a block of memory. And you know exactly how big the type is of the elements, how many bits the element values need. And so your array can actually be very compact in memory. An array list, on the other hand, needs to be allocated a lot more memory to do the same thing, but the trade-off there is you get the flexibility of all the methods and the dynamic size of that array. So both have their place. Most often you would want to use maybe an array list because it's flexible. Sometimes you can just use a normal array. It also makes use of, the array list also makes use of Java's generics typing system. That's something we might touch on at the end of the term, depending on how much time we have and the work we've covered. But generics are also very, very cool. So you can insert and remove elements from anywhere. To declare a new array list, you give it a type, you create a new array list with that type, and then there's the generics, right? So an array list of strings, you'll put in the type that you want. Then you can create an array list, you can add things, and you can remove elements. You can also kind of look through and sort it and do a whole bunch of really cool stuff. So one of the big differences is that instead of array.length, you will use the count method, which will return the number of elements. Instead of array index, you will say get this item. You cannot use primitive data types, as you might have found. You have to use their class implementation. So instead of int, you need integer. To convert the array list to an array, which is something you might want to do, you might want to read in a variable amount of data. And then when you no longer need to add or remove elements and need all of that fancy stuff, you can convert it into a normal array, which is a lot more memory efficient. You can call .toArray. Okay, so this is a method you might not have come across, but might be useful. Okay, so let's talk about some cool tricks we can do with arrays. This is more from, I want to say, old school programming in the days of C, when they didn't have all the nice fancy classes and array list things. They kind of had to develop techniques to work with arrays that were cool. However, the downside is that we could start over here and be like, hey, we're going to do something really cool. And then by the end of it, we just hit ourselves in the face with a rake because we tried to be cool. But the journey itself was quite nice, right? So these tricks are risky. Make sure you understand them if you want to use them. Sometimes the benefit isn't good enough for the risk. So a 2D array can be represented with a one-dimensional array. This is the first trick we're going to look at. Instead of having my 2D array being an array of arrays, you can use a fake 2D array, and you can say I want 3 rows by 4 columns. So the new array is, 12 elements long, and then you index it by saying the row, right, times the size of the row that you want plus the column index will give you that element. Does everyone understand this trick that we're doing? We're just flattening the array. And then you index it using that arithmetic expression. Okay. So
what's this doing now?
Say again.
I'm not sure. Oh, so just please re-explain what you're doing.
Okay. So if we don't feel like working with an array of arrays, when we create a multidimensional array, we specify the number of rows and the number of columns. We can instead use a single one-dimensional or a flat array and then use some special indexing math to represent the different rows and columns. So over here, we will create 12 elements. So let me actually draw this out. In this array, we have something that looks like this with 3 different arrays, and then each of these is like this. My drawing is horrible, but they have 4 different elements. I'm not sure if I got that right. 4 different elements each. However, what we can do here is we can create one really flat long array, right? So over here, if we want to index 0, 1, we will go to 0 here, and then we will go 0, 1, and we will access this element. Just make this blue. We'll access this element. However, if we had a flat array with 12 different elements, let's do this for now. The way we would access 0, 1 is we would say 0 times the length of the row, which is 3, or the length of a row is 4, sorry. 0 times 4 plus the number of columns, which whatever the index of the column is, right? And what we say here is that we want to skip over every 4 elements, because those represent our rows. You can imagine this is 0, 1, 2, 3, 4, so on and so forth. If you indexed all these from 1 to 12, from 0 to 11. Instead, we want to get it mapped onto this flat array. So 0, 1.
I could be wrong, but isn't the flat one better than the 2D one? Because the flat one is just one big draw. It's like one big thing. You could just put everything in there.
It could be, but the trade-off is that now you have to do a bunch of math to access the correct element, right? So 0, 1 would be over here. This would be 0, 1. And then, the final index, if we wanted to go 0, 1, 2, element 3, right? Because this is 0, 1, 2, 3. If we wanted to go 2, 3, we actually need that to be 11, because it's going to be the last element in this array. And how do we get it 11? We'll say 2 times 4, which is the length of each row, or the number of columns in each row, plus 3, which is the index over there, right? So you're doing this kind of math every time you want to access an element in the flat array. Does that make sense? Can you see the output? Sure, we'll do a demo.
Oh, I see. You have to do math for the flat one, whereas for the normal
Yes.
one, you just simply
You can
put
just
in
address
column
it.
and a row.
Yeah, exactly. So we can definitely look at it. Let me just make sure we get through all of our tricks. Yeah, and then we'll look. So over here, you can see this is how it works, right? Element I is the row times the number of columns plus the column. So rows 1, 2, 3 plus the columns. Does that make sense to everyone? Yeah. So there's the index, these are the row indexes, and these are the column indexes. So that's kind of how it changes. You know, this comes, so you're doing this math, that's the trade-off, which, you know, you could introduce bugs. Another cool trick is that you can wrap around elements. So this is maybe useful if you have like log files, but you only want to keep 100 logs, like the last 100 strings of log files, and you want to wrap. So once you entered the last line, you want to then start from the oldest log lines and keep filling the array until you reach the end, and then keep going back. The way we do this is we use the remainder, the modulo operator. So it's a way for us to keep safely within bounds of the array when we do this. So if the length of the array is 5, the last index is 4. So if you use index percentage sign length, right, which is 5, these values will only ever be, so the remainder of this will only ever be 0 to 4. Okay. And so this way we can keep looping through. So even if we went I from 1 to 100, with this operation, we will only access the indexes 0 to 4 over and over and over and over again. Does that make sense to everyone? So this is a way for us to wrap around on arrays. And this is also something that's quicker and easier to do with arrays than array lists. So if we had the following, I have an integer array of 5, and I said, okay, from I 0 to 100, or 99, the index is the current I value divided by 5 and the remainder of that, and then we just assign that index. So I would recommend go try this at home and see what it outputs. We might also be able to look at it. I get the feeling we're running out of time, but go try it. It's quite cool. And the log file, example is important. So maybe think about that log file example, especially towards tomorrow. However, one of the warnings is that this technique can cause data to be overwritten. You are at home, yes. Sorry, do it after the lecture. Yeah, sorry, my my fault there. Don't do it at my house, do it at your house. Might be a better expression. So with this technique, obviously, you can just start overwriting data in an array. Okay, so how would you represent a 3-dimensional array as a single 1-dimensional array? I'm leaving that up to you. You might have the idea of like rows, columns, and depth. How would the indexing work? What is the formula for indexing an n-dimensional array as a 1-dimensional array, right? So this is like a more general, so this is like a generalization of making a flat array. Okay. Then there's some reading here. Go and have a look at the difference between deep and shallow copies. This is the idea of array equivalence. So if you want to create a copy of an array, just assigning the reference or transferring the reference to another variable is not going to cut it. You need to actually copy all of the contents of that array as well. Array lists have a different way to do deep and shallow copies, which is also might be an interesting thing to look at. Right, so with that, we're going to look at some array tricks. I think someone wanted to see the output of a one-dimensional array. So let's go have a look at a flat two-dimensional array and the output thereof. So over here, we are in a little Java thing. We can create a file. Let's just have a look at the code samples. We can open up scratch.java. And here we have array lists. So for now, we can just get rid of all of this. Let me increase the font. Get rid of all of this. And then we say over here, a integer array, my flat array, because why not? And we'll give it some values. But we want to make it a two-dimensional array. So let's look at, say int num rows. I think it's meant to be num rows, num columns equal to, we want a 3x4. Let's see if that will work. And then we say a new integer array, the number of rows times the number of columns. So that's how many elements will be in the final array. Because we've written some code and I'm unsure of this line, something I like to do is to just use the compiler to check if I'm actually writing sense or if I'm writing nonsense. And identifier expected. Okay, so we did write some nonsense. So we want to separate this out and make this an integer and do that and then say 3. Okay, so once we've done that, we can try it again. Error expected. Need to say new. And reach the end of file while parsing. We are missing that one there. Okay, so you can see how I'll often use the compiler to check if I'm writing correct code. So now we have an array, and then we'll do something here, print the array. Okay, and we'll use a for loop. So for I in I, let's make it int I, right? In our my flat array. Then we say system.out.print line I. Okay. Let's see what this looks like. We'll compile and we'll run it. So we just have 12 different elements of 0 because that's the integer. Now, what do you guys want to see first? Do you want to see indexing in a two-dimensional way, or do you want to see the wraparound? We can do either one. We can do indexing or a wraparound. A wrap. Okay. We'll do a wraparound first. So let's say we have 12 elements, but now we want to go from 0 to 1000, right? Inclusive. We'll make it inclusive. 1000 j plus plus. And then for each of these, we want to say that my flat array, right, at a specific index is equal to j. And so if we just try j, let's see what will happen. So for now, we'll do this. Sorry, just give me a second. We'll just comment this out, and we'll see what this will do. So we'll compile it, and we'll run. You can see we have a exception, right? Index is out of bounds for length 12, so we didn't even get that far. However, if we say that int our index is equal to j modulo or remainder array flat array dot length, right? Then we say at our index. Now we can see that hopefully it'll run. We made some changes. We need to recompile. It compiled, and then we run, and it ran, but we didn't get any output. Now, if we take this and we print it out, so like that. If we compile and we run it, we can see that we got the last of the 1000 items, right? However, you will see that we went from 996, 997, 998, 999, 1000. We wrap around, so we go back to 9989. So everything before this has been overwritten, and then this is where it went. So it went from 995, wrapped around to 996, and then continued until it stopped over here. Does that make sense to everyone? Okay, so let's look at multiple indexing. So now, instead of just printing it all out as a flat array, we want to print it out as a multi-dimensional array. So actually, we're going to take this, get rid of it, and we'll say for int I equals 0, or we'll do it like this, make it a bit more easy to see. Row is equal to 0. Row is less than the number of rows. And then row plus plus. And then we add a nested for loop for int column is 0. Column is less than num columns. And column plus plus. So now we have the indexes of rows and columns. We can say system.out.print system.out.print my we'll make it print line for now, my flat array, right? And we need to index this. So we will say my flat array. We don't have a specific index, but if we want to pick the row, we say the row times the number of columns plus the column index. Okay, so we want to check if this works and if it gives us everything, so we can quickly compile and run. You can see, because we got the exact same array we printed out last time over here, that our indexing is working correctly. All right. So now if we just want to make it a bit more, bit prettier, we can say print instead And then after every row, we say system.out.println, just an empty string. Why not? And then over here, we want to give it a maybe a space. Then say system.out.print our thing. So let's see what this code will give us. Try to compile, and then we run it. And now you can see we have our two-dimensional array. Okay. So it's printed out everything from 996 in order. So the first row, the second row, and the third row. Is everyone with me? Does everyone understand? So the number of columns we said is 4. So we have 4 different columns. The number of rows we said is 3. So we have 3 different rows. But it's all stored in a single flat array. Okay. So I think that is where we will stop for today. Tomorrow we will have a consultation session. Tomorrow at 12 your assignments will be released, so definitely keep an eye out for that. And come to the consultation to ask some questions. Feel free to do so. I will make sure to upload lecture 3 and lecture 4 to eCanva and put them under the lessons tab. However, this video should still be available on this channel. Otherwise, I will see you tomorrow. Enjoy the rest of your afternoon, enjoy the rest of your evening, and good luck for any assignments or any lectures you have coming up.
And the PDF sent to please, sir.
And the PDF. I will make sure to do that as well. It'll be structured like, if you have a look at the lessons, I think lecture 3 is up, or lecture 2, where we have the PDF slides and the video and the code samples all in one page. Yeah. So with that, I think we'll cap it off. You are welcome to enjoy the rest of your evening, and we will see each other tomorrow.
Thank you, sir. Enjoy your day, sir.
You too. Bye, everyone.